Dear friends, welcome to a lecture on complex analysis. In this lecture, we shall study some problems, solution of some problems on roots of complex numbers. Earlier, we have studied how to find roots of a complex number. There we have written a formula also. And to find roots of complex number, a complex number is written in exponential form. That is, z is written as r into e power I theta. And then its nth root is obtained by taking 1 by n power as r raised to 1 by n, and again this periodicity of the argument is to be used, r e power I theta plus 2k pi, because the argument may be increased or decreased by a multiple of 2 pi, and therefore this will become e power I into bracket theta by n plus 2k pi by n. And if you put the values of k as 0, 1, 2 up to n minus 1, we will get the distinct n roots of this complex number. So this is the formula and the method that we have seen earlier in our earlier lecture, and now we shall solve some problems on it. Solution for the first problem A, and this is minus 8 into root 3 I power 1 by 4. So this complex number minus 8 is common, but we shall take we have to take the positive real number as common, which is 8, and therefore we shall write minus 8 into root 3 times I raised to 1 by 4. So this we can write 8 common, and with the power is 1 by 4, and in bracket what remains is minus 1 minus root 3 into I, and that is raised to 1 by 4. Now what we shall consider is this as z and then we shall express this z as in this form, that is exponential form, and then we take its power as 1 by 4. So first let z be written as minus 1 minus root 3. We shall have to write its modulus and argument. So let suppose this as equation 1, let z be minus 1 minus root 3 times I, or in usual notation it is x plus y into I, and here therefore r is absolute value of z, and that is under root of x square plus y square, that is minus 1 square plus minus root 3 whole square, or this is 1 plus 3, which is root 4, and positive value we have to take, that is 2, root 4 is 2, and theta is equal to, here we shall write the principal argument of z, and that is argument z, and this x is negative, y is negative, x is minus 1, y is minus root 3, and that means this lies in the third quadrant, and in the third quadrant the principal value of argument is negative pi plus tan inverse of y upon x, and this is minus pi plus tan inverse of y is minus root 3 and x is minus 1. So tan inverse of root 3, and that is minus pi. Now you see tan inverse of root 3 is pi by 6, and that is we know what is tan inverse of root 3. So it is sine 60, that is sine 60, and which is pi by 3. So this is 60 degree is pi by 3, because tan pi by 3 is equal to root 3. Sin pi by 3, that is sin 60 divided by cos 60, and that is right. So it is minus pi plus this is tan inverse of root 3 is pi by 3, and therefore this is, now this is minus 3 pi plus pi, it is minus 2 pi upon 3. Minus 2 pi divided by 3. So this is what is theta, and therefore z is r e power I theta, and that is r is 2 and e power I into theta is minus 2 pi by 3. But this we should write theta plus 2k pi, and that is 2 e power I into bracket minus 2 pi by 3 plus 2k pi, and where k takes values as any integer, and this is the value of z that we have, and we shall use this value of z, that is here in equation 1, and therefore equation 1 becomes, with the help of this expression for z is minus 1 minus root 3 into I, and therefore equation 1 becomes using this in 1 we get, and see, this is the equation 1, that is required root, fourth root of minus 8 into root 3 times I raised to 1 by 4, and is equal to 8 raised to 1 by 4 into, so this is z and that is 2, so whole is to be written under 1 by 4 power, and that will be, I shall write in bracket 2 e power I into bracket minus 2 pi by 3 plus 2k pi and raised to 1 by 4, or that is 8 power 1 by 4 into 2 power 1 by 4, and this we shall write, this is to be divided, exponent is to be divided by 4, and that I shall write exp, exponential in bracket I will keep as it is, and into bracket this is to be divided by 4, so that gives minus pi by 6, you check it, this is 2 pi divided by 3 into 4, and this gives pi by 6, and here it is divided by 4, and that will be plus k pi divided by 2, and thus these are the values, this is the expression for the fourth root of the given complex number, and here we know the fourth root of this will have 4 values, and for to get 4 distinct values we have to put k is equal to 0, starting with 0, 1, 2, 3. This gives the distinct values of the 4 roots, and other values of, here we have written k is any integer, positive, negative, etc. But this will generate repeated values, and therefore distinct roots will be given by only these 4 positive values, and we shall consider these values 0, 1, 2, 3, starting with 0. And now this is our equation required, that is minus 8 root 3 into I power 1 by 4, and we put k is equal to 0, 1, 2, 3 in succession to get the 4 roots, and so let us suppose, but this is to be simplified. You see, 8 into 2 is 16 power 1 by 4. 16 power 1 by 4 is written as 2 power 4 is 16 and raised to 1 by, so this is simply 2, and thus we replace this by 2, and that is I shall replace here itself and this value is 2. 2 into exponential of this. Now putting these values of k, we shall get, let us denote the roots by C0, etc. Let C0 the roots be, let the 4 roots be C0, C1, C2, C3 corresponding to the values of k is equal to k is equal to 0, 1, 2, 3 respectively. That means if you put k is equal to 0, we will get C0. Put k is equal to 1, we will write the root as C1 and so on. So thus this gives, put k is equal to first 0 to get C0. So putting k is equal to 0 in 1, we get C0 is equal to, C0 is, now you observe this value on the right side of 2. So this is, we shall suppose this as 2 and put k is equal to 0 in 2, we get, now C0 is 2, exponential of k is 0, so this is I into minus pi by 6, exponential I into minus pi by 6, and that value is e power I minus pi by 6. By Euler formula, we have this as C0 is equal to 2 into bracket cos minus pi by 6 plus I sin minus pi by 6, and pi by 6 30 degree. So this is equal to, and that value is 2 cos 30 is cos negative of theta is same as cos theta, and that is cos 30 degree is, we know, is root 3 by 2 plus I, and this is negative, sin of minus theta is minus sin theta, minus I, sin 30 is half, and thus this value is, this 2 cancels and we get this as root 3 minus I. So this is C0. Now next put k is equal to 1 to get C1. I shall write below. Putting k is equal to 1 into, we get C1 is equal to 2 exponential of this k is 1, and that is I into bracket minus pi by 6 plus pi by 2, and you see minus pi by 6 plus pi by 2, this angle is minus pi by 6 plus pi by 2, we shall multiply by 3 pi by 2, 3 pi by 6, and therefore this is 2 pi by 6, and that will be pi by 3. So this value is pi by 3, and that is 2 exponential I into pi by 3, and this will be, I shall write here. Let us check the calculation we are doing correctly, and this C1 is 2 into bracket cos pi by 3 plus I sin pi by 3, and there we have angle pi by 6, here we have pi by 3, and that is 2 into bracket cos pi by 3 means 60, cos 60 is half, and plus I sin 60 is root 3 by 2, and this 2 cancels with the this 2 at the denominator, and therefore we get C1 as 1 plus I root 3 or root 3 times I. So this is the value of C1. Now we shall get C2. Put k is equal to 2 into, we get C2. C2 is equal to 2 exponential I into minus pi by 6 plus k is 2 pi upon 2, that is pi, minus pi by 6 plus pi. And what is this angle? You see, take the LCM as 6, so this is 6 pi upon 6 minus pi, and that is 5 pi by 6, and again 5 pi by 6 is to be written as 2 exponential I into bracket, and this we shall write, or we will write it as it is. So there is no need to express this in other way, because we shall use allied angle formula to simplify C2, and this is 2, and exponential of this means cos pi minus pi by 6 plus I sin pi minus pi by 6, and you see this will be C2 is equal to 2 into bracket cos of pi minus theta is cos theta, but in negative, because it is in second quadrant. This angle lies in second quadrant, cosine is negative. So minus cos pi by 6, and plus in second quadrant sine is positive, and sine remains sine pi by 6, and pi by 6 is 30 degree, and therefore this is minus cos 30 is root 3 by 2, and sine 30 is 1 by 2, and therefore C2 is equal to, C2 is, this 2 cancels with this one, minus root 3 plus I. This is C2. Now what remains is the last root, that is C3, corresponding to k is equal to 3. So put k is equal to 3. Put k is equal to 3 in 2, we get C3 is equal to twice exponential I minus pi by 6 plus 3 pi by 2 plus, here it is 3 pi by 2. And what is the minus pi by 6 plus 3 pi by 2? 3 pi by 2, we take the LCM as 6, denominator as 6, and that means we have to multiply by 3. So yes, and this is 3 into 3, 9 pi by 6, and so it is 8 pi by 6, and this is to be considered or to be written as say pi plus, if you consider pi, and then it will be 8 pi upon 8. So we will express this as pi plus see, this is 8 pi divided by 8 will be pi, and that will be minus say pi upon 6. If you consider 6 minus, so this is to be written in terms of pi plus or minus, and 8 by 6 will give 1 plus. So 8 by 6 we should have to express as 6 by 6 plus 2 by 6, and that is 2 by 6 is 1/3. So this will be pi plus pi by 3, the angle, and that is 3 pi plus pi, which is 4 pi by 3. So 4 it is the same 4 pi upon 3, and therefore we will write this as pi plus pi by 3, and there that is this C3 is 2. So what we have to write is C2. What we have written is root minus root 3 by 2 plus, so it is I into 1 by 2, and because we finally have to express these values, and that I have written here is minus root 3 plus I. This is the value of C2. Now C3 is this value pi plus pi by 3. So it is 2 cos pi plus pi by 3 plus I sin pi plus pi by 3. And that I shall write here. So C naught we have, and this now in the equation the use is over because this is the last value, and so I shall write here this is 2 cos pi plus pi by 3. Again cos remains cos, in the third quadrant both are negative, and minus cos pi by 3. Minus cos pi by 3 is minus root 3 by 2, and this is again minus sin pi by 3 1 by 2, and therefore this value is C3 is equal to, it is minus root 3 minus I. So thus these are the values of the fourth root of minus 8 root 3 into I, and thus we shall now list it. Thus the 4 roots of thus the 4 roots of minus 8 root 3 I are C naught, that is root 3 minus I, C1 which we have here 1 plus root 3I, C2 it is here minus root 3 minus I plus I, yes, and C3 is minus root 3 minus I. So thus, these are the roots of 4 roots of the complex number minus 8 root 3 I raised to 1 by 4. What further asked is find all roots in rectangular coordinates we have obtained. These are the rectangular coordinates which are written in the form of x plus I into I, and now express them, exhibit them as vertices of certain squares and point out which is the principal root. Here the principal root is this one, C naught is the principal root. The principal root is corresponding to the value of k is equal to 0. Root 3 minus I, and we exhibit these as in a rectangular form. We have exhibited, and these are 4 roots will be 4 vertices of square, 4 vertices of square inscribed in a circle, and radius of that circle will be 2. So I shall write, we shall draw the figure here. the radius is 2, and you see this is root 3 minus I, the principal root is. So root 3 and the corresponding coordinate will be root 3 minus 1, and therefore that will be in this fourth quadrant, root 3 minus 1, say somewhere here. And now the other will be exactly having opposite to this, that will be this one, 1 root 3 in first quadrant, 1 root 3, and then the corresponding will be on this side, or we will have like this. These are the vertices of the square inscribed in this circle. This is C0, C1, C2 and C3, and the radius of the circle is 2. So thus in this way we can find the roots of complex number, and we can express it as a regular polygon which is inscribed in the circle. So thus we have solved the first problem, and the second I shall give you as a homework or problem for practice, and the answer I will tell you for second problem. See, there is a correction in the value of C3. C3 we have written like this, 2 into bracket minus cos pi by 3 minus I sin pi by 3. This we have written correctly, but while writing the value of cos pi by 3 I made a mistake. Cos pi by 3 cos 60 degree is half, and sin 60 is root 3 by 2, and thus this value is minus 1 minus root 3 into I, and this is to be corrected as C3, minus 1 minus root 3I. So please note it, and the remaining are correct. So C0, this expression is also correct. C0, C1, C2, C3 lie on the vertices of a square which is inscribed in circle of radius 2. So in this way these are the roots, and this is the first is the principal root, root 3 minus I. And for this problem B, the solution is, so B you should solve yourself. Solution for B, try yourself. The answer is, likewise you can solve this, and you see it is the answer I shall tell you is plus or minus root 2 into bracket 1 plus I. There are two roots, root 2 into bracket 1 plus I and minus root 2 into bracket 1 plus I, and similarly the other two are plus minus root 2 1 minus I. So this is easy. We can express this as 16 raised to 1 by 4 into minus 1 raised to 1 by 4, and 16 raised to 1 by 4 is 2, and this minus 1 raised to 1 by 4. Minus 1 can be expressed as e power I into pi, and so on. We can add here in pi 2k pi and put the value of k as 0, 1, 2, 3. You will get the 4 roots like this. So please try this second problem yourself. Thank you for watching the lecture.